Okay, I'll get started now. Before I get started, I just want to talk about certain things. Uh, so I'll just get started quickly because that'll take some time. One of the things I want to discuss today is that some of you are sending me your Goodwill Hunting, the Breakthrough Challenge entries, and I'm seeing them. Okay. What? I didn't get that. Okay, so we get started. So there's a lot going on. So I just wanted to get to what you say, uh, just to discuss this bit. Okay, so this is for some of you who are sending me the entries, and uh, just to be honest, they are okay right now, whatever you're sending. And I just want to comment on that. What about previous quiz results? Oh, I have not released them. Yeah, I'll release them. Uh, so anyways, with that being said, just want to discuss this quickly. Okay, this will take about 10 minutes. Okay, what is that? Yeah, I know. I just realized you didn't get the previous quiz results. Okay, now with that being said, a few things here. Is there a quiz today? Yes, you'll have a quiz today. Okay, you'll have a quiz today. If you want the release of your marks for some of you in the background, yeah, I'll do that. Give me a moment. Induction PPT, PPT coming through if you want it. I was not there yesterday. There was no class yesterday from my side. Okay. Now, where is it? Where is it? Where is it when I need it? Yes, got it. So, some of you didn't get your marks, you told me. So, give me a moment. You guys are Kalpana Chawla, right? Oh, yeah, that's what you are. Okay, Murari. The first half, don't worry. I'll just release your marks and then we'll get over with it. 1 second. Everybody take a break 1 second. I'll just do this. Take a moment to release your marks. Yep. I'm just going to import the grades and then release your marks. Yep, done. So you must have received your marks in Google Classroom. Just check it out. Okay. Lens law, you guys didn't get the marks. Okay, we'll look into it some other time. Now, Satvika is here, admit. Okay. So a few things I just wanted to talk is about, I was looking through your videos and to be honest, there are many things you guys have to sort out. Okay. So this is not just for people participating in Breakthrough. This is for everyone who's going to do PowerPoints in the future, who's going to, I don't know, present something in their classroom, whatever you do. I just want to tell you what are the things you need to get them right. Okay. Well, just a discussion on that. I'll do this very quickly. First things first, I think this is something you need to know. Okay. Keep it at the back of it. You can appreciate it only when you're good at it. Okay. So make sure this is very important. This line is very important. Uh, I've just sent you one of the marks. So you can appreciate only when you're good at it. So for example, when you look at, let's say, I don't know, some art form or whatever you see, let's say, an animation, let's say, that happens on a screen or something like that, you can appreciate only when you know how to do it. Okay. So if you're still not in that zone where you can appreciate it, then you are rocket right there. So keep this at the back of your head. Okay. Second thing, I'll be using 3 videos just to demonstrate what is required and the different style formats. I'll open these videos in some time. Before I get to them, third one is this one, which is 3 Blue 1 Brown's colliding blocks video. And then there is projector illusion by Physical. Now, first of all, choosing the topic. You guys are very, very confused about this, most of you, and messing it out a lot. First of all, choose a topic which you're comfortable with first. That's the most important. When is last 20th? Second, when you choose a topic, make sure you are capable of capable of dealing with that topic. Okay. If you're comfortable with biology, go with biology. Do not force yourself into a topic. Okay, that doesn't work. That really doesn't work. Okay. Now, next part is research. Now, this is a part where all of you messed up. Whoever sent me, almost all of you have messed up this part. Research, not enough. Okay. Now, this is an aspect I'm going to discuss a lot. Yeah, this is for the breakthrough challenge. Yes, this is not just for the breakthrough challenge. This is for anything you're going to do in the future. Okay. Anytime you take up a class, anytime you do a PPT, anytime you do something for that matter, this is going to matter. Research. You guys are lacking in research a lot. please make sure to fix up the research. So research, to be honest, when I prepare for a class, freshly on a topic, it takes me about 12 hours to prepare for a 1 hour class. 12 hours, roughly, on average. Okay, when I mean 12 hours, in that 12 hours, approximately 10 hours go into just reading. You have to sit and read and read and read. You're supposed to do a video, okay? This goes on forever. You have to sit and read, okay? Look into Breakthrough Challenge online, okay, for that. So please make sure you do a lot of research. I'll tell you why this matters later. Second one, next, after that, what matters, once you have the research done, is storytelling. This is also something you guys lack a lot. Okay, the content flow matters a lot, guys. You know how much it matters when your grandma tells you a story, grandma's story. If somebody has told you a story, you want to listen to it only when there's a flow to it. So make sure, stand-up comedians are good at this because they always tell you a story. I don't know whether I realize you over stand-up comedy. They always tell you a story. There's a flow to it. Okay, so make sure you have a flow. I'll come to this in some time when you watch the video. Okay. Next bit is something that you guys mess up on. And please, by the way, my professors used to tell me always in this thing, and when you do a PowerPoint presentation, make sure you have a storyline. A story should be involved. Next, style and format. Now, this is something you guys are messing up also. Choose a proper style and format that you are comfortable with. For example, if you're going with documentary, go with documentary. For example, you could go with animation. You can go with animation. You could do a blend of both. That's also fine. Okay. In the video making business, you got to choose a format and a style. And this could mean for a PowerPoint presentation in a class, it could matter what you think about. Okay. So when you're making a video, make sure you stick to it. You can get in the crazy. You can try stop motion. You can try crazy things. That's later. Okay, but choose a style. Keep a style at the back end and go about it. Okay. Next part, scripts. Now, scripts are where scripting you guys are messing up also. First of all, some of you are writing the scripts, but to be honest, you might have write about 10 scripts before you get the proper script. Okay. If you think your first script that you wrote is the best, no. You might have write it multiple times. I'll come to that, Nidhi. Yeah. So there are many things that you need to involve. Second thing, script is, if you look at Minute Physics, how he does his video, you got to please go and check out his videos. Okay, what he does, he has done a video on how he films. Okay, and you'll see that he explains the process, and he shows you that it takes a lot of time. Okay, a lot of time. I'm not talking about 15 minutes. I'm talking about days. Take days to write a script. Okay, don't take 10 minutes, 1 hour, 2 hours. They're not enough. Then you're not done enough research. Okay, scripts take hours. Scripts probably take, for some of them, scripts take months for certain videos. Okay, so you got to have that part element in you. Okay, next bit is filming and rendering. Now, this filming and rendering part is where things get a little bit complicated. This is where CFL might help you a little bit, but there are certain details you need to be careful about, and this I think we can fix later. This is something you don't have to bother a lot. When it comes to filming, certain things matter. When you shoot in your house, do not shoot a crappy video. Cameras matter. Okay, whatever you say, no matter what you say, cameras matter a lot. High quality videos matter a lot for winning. For this aspect, I think CFL will help you with this. For now, you can just shoot a low-res video and send it. We'll deal with it. Second, now, going back to these videos, if you're going with animation, please learn the process of how Kurzgesagt does this video. In fact, there's an entire video done by Kurzgesagt on how they make a video. It takes so many hours, guys, for each of their videos. So many hours. It's not a little bit of work that goes in. Each animation is taken care of, and because of that, they are a top YouTube channel or whatever. Okay. There's also infographics, which does, I don't like it much. Good enough research, but Kurzgesagt takes months to do a video. Okay, it does research on it for a long time. Now, with that being said, there is Minute Physics, Minute Earth, and ASAP Science. This is where you don't have to show your face a lot, but the careful bit you need to be careful about, you need to look into these type of video formats, is make sure whatever you draw on the screen is good enough. It shouldn't be stupid. Okay, it shouldn't look horrible. Okay. One more thing I need to add. Some of you are asking, should we create animation always? No, animation is not everything. Even if you don't have animation, you can produce a great video. Okay, animation is just a cherry on top, unless you've completely chosen animation as your format, which means you have to do great with animation. You have to go beyond what you could have delivered without animation. Okay, that's much more challenging, to be honest. Okay, now if you're going with it, try to do a mix. Like, for example, Minute Earth is completely animated and stuff like that. Next, With that being said, then there is TED-Ed. TED-Ed format is completely different. SciShow format is completely different. This is where animations come in again. And look, the thing about TED-Ed is they catch you with the title. They have this catchy titles. Why do cats act weird and stuff? And you already know what you want to watch. So let's say it's 3 o'clock in the morning and you're bored and you're going through YouTube. You know how YouTube spiral works, right? You just go in there and you're stuck forever, okay, watching one video after the other continuously. So in that format, this works, okay. But then you got to be very careful with the animation here. Their animations completely are great, okay. So you got to keep track of that. Next part, okay. Now you need to understand the winning format. This is the format that has won over the years in Breakthrough Challenge or many other places. That is the format which Up and Atom follows, Physics Girl follows, Veritasium follows, and Vsauce. All of them follow this format. Now, the format is a mix of documentary making and animation. It's a good blend, okay? It's a well-known blend and it works always and is always won at Breakthrough. For a reason, Vsauce shoots in exotic locations. He goes to these locations and shoots them on a top of a mountain or something like that. He's always walking and it's a documentary format. Okay, documentary. This has been the winning format for now, but it works. It works. It mostly works. I'll show you why this video works in some time. Okay, why? Next, location matters. Look, context matters. Okay, so Vsauce, this particular video will give you an idea of the filming aspects. Okay, where it has been, why it's been filmed. Now, going back, I think I didn't show you this. If you are interested in understanding documentary type filmmaking, I would recommend you look into Tom Scott. Okay, he's a British YouTuber and does amazing documentaries, science documentaries. This is something I would recommend you guys to look into. Now, this is the person who won last year. Okay, the 2019 winner. His format was documentary making itself, the same format. The way it works is Veritasium style. Okay, quite effective, really worked for him. We'll analyze it in some time. Why his video worked. I would say the best video so far in whole of Breakthrough, and this breaks the record, is her video. Okay, she did an amazing. This is the 2017 winner. I think it was better than even 2019 winner because this had a combination of animation, good combination of animation, as well as good documentary making. Yeah, going around thing is no, maybe we don't know that. If you want to get in humor, I'll come to that. There's this guy. Okay, now this format is a risky one to try. I would personally say it's a very, very risky thing to try. Okay, humor is complicated. I'll come to that in some time why, but this guy's format is not, what to say, not advised, but if you're doing it, do it carefully and do it right. Okay, but one thing you got to appreciate about this guy's video is he actually gets himself involved in the video, and that matters. He's part of the experiments. He's part of the topic. Okay, and that matters. That is something you've got to pick from here. Okay, so keep this at the back of your head. I'll come to other things later. First, I want to just show you the basic various videos I just mentioned. I just want to show you what makes them different. And this is a format I've been involving in teaching a lot. I told you, right? I used to prepare for 12 hours, 13 hours to make a class. Yeah, those days I used to use these techniques. Okay, but I don't know. This is not possible always. When you have 2 hours of classes and when you have 4 hours to prepare, it's impossible to deliver something like this. But I'll show you this video just to give an idea of how Vsauce does it. And I can tell you it's a winner. I'll show you why this video would win. It's just a 4-minute video. It's about how heavy is the internet. What is the weight of the internet? Now the topic is catchy. I get it. The topic is catchy. But I want you to see how he starts. Okay, and this is very, very important, the way he starts. Watch the video. I try to optimize the clip. Hope it doesn't get blurry. Watch this.
Hey, Vsauce, Michael here, and this strawberry weighs about 50 grams, which according to Russell Seitz also happens to be the weight of the entire internet.
Don't you think you're hooked into the video right away? That 1-2 lines that he said, and right now you want to watch the entire video. You know that you want to watch it. Okay, audio quality matters. I'll come to that. But he just told you that strawberry is the internet. Okay, he just hooked you by showing you what do you say, just the strawberry, and then you're caught onto the video. Got it? So this matters. So the opening of the video always should contain something that blows people's minds. Okay, that matters because that is when you want to watch the video, to create a situation where people want to watch the video. Yeah, fine, Murali, we'll look into that. So that part matters a lot. Now, if you think that that's not there everywhere, everybody does that. Okay, you want to you watch this video, guys? Have you watched? Wait a second. Have you watched this video by Colliding Blocks by 3Blue1Brown? How many of you watched this? No. Have you guys watched it? Then you guys are losers if you have not watched it. So yeah. Okay. Some of you watched it. Yeah, no offense. But the idea is this video is amazing because it calculates pi. Yeah, very famously calculates pi. Now, what this video, you'll get an idea of what I'm talking about. When I mean this is one of the best videos of 3Blue1Brown and why it got so many views, millions of views. And he also explains this format, how he does the videos, and there's a pattern to it. Okay, give me a moment. I don't know why is internet behaving this way. Damn it. Microsoft is struggling to catch up with. Zoom is acting weirdly. Okay, done. If you see this, the beginning, the way he starts is amazing.
Last video, I left you with a puzzle. The setup involves two sliding blocks in a perfectly idealized world where there's no friction and all collisions are perfectly elastic, meaning no energy is lost. One block is sent towards another smaller one, which starts off stationary, and there's a wall behind it. So
I've shared the screen, right? Should be able to see it.
That the smaller block bounces back and forth until it redirects the big block's momentum enough to fully turn around, sailing away from the wall.
There are two blocks which are colliding, one stationary block, and after the collision, you count the number of collisions, how many collisions happen with the wall and the block. Is this fine? Got it? Okay. I know it's a little blurry, but I can, yeah.
If that first block has a mass which is a power of 100 times the mass of the second, for example, 1,000,000 times as much, an insanely surprising fact popped out. The total number of collisions, including those between the second mass and the wall, has the same starting digits as pi.
The number of collisions that happened was exactly 3141. Okay, when this was 1 kg and this was 100 to the power 3. Okay, somehow pi popped up in physics. Okay, I know the video is paused, but hope you realize that somehow pi popped up in physics, guys. That is not something you would expect on a daily basis to see. Okay, I hope there's no lag right now. There will be a lag, but I think the blurry part is solved. Blurry problem has been solved. Yeah.
In this example, that's 3,141 collisions. That first block was 1,000,000,000,000 times the mass. It would be 3,141,592 collisions before this happens.
Now this is surprising.
Almost all of which happened
onto the video because you're shocked. Like, how does pi pop up in a physics collision problem like this? Okay, it doesn't make sense. I don't even see a circle. I don't see pi. I don't know where it's popping from, but it just comes up. And people are immediately hooked onto this and they watch the next 15 minutes for that reason, even though it's a 15-minute long video. Okay, so this video, so the point is in the beginning, you need to show them something that shocks them. The solution is amazing. You guys have to check it. There's a way to solve it using optics and light. Okay, this problem can be solved using optics and light. It has weird connections. This is one amazing. Why does this happen? You have to watch the video. Okay. The third video, which I highly recommend, is Physics Girl. Now, her format is a winning format for a very important reason. Her format involves, again, watch what she does. Okay, you need to watch it. You'll understand what I'm talking about the moment you see it. Damn it! Why is it not starting? Okay, 1 second. I hope this solves the problem. Okay, it started. Yeah, watch what she does. I'm sharing the video now, high quality. Trying to have a high quality video, but yeah.
Hey, I'm Diana, you're watching Physics Girl, and I want to show you something that I made. It's a video.
You might know about this.
Hey, I'm Diana, you're watching Physics Girl, and I want to show you something that I made. It's a video with actually a strong warning. I don't know what legal language I'm supposed to use. Epilepsy. Warning, this video may potentially trigger seizures for people with photosensitivity.
Reason, I think it's caused by my weird internet. But 1 second. I know there's a black screen. I understood that. I got it. 1 second. Yeah, if possible, watch it on your own on this thing. You can only hear. I know, I got it. Give me a moment to switch to a different internet. That'll solve the problem. This video demonstrates something very important, something very, very important. Okay, can you guys see it now? Is there a lag? This should be better.
Actually, strong warning. I don't know what legal language I'm supposed to use. Epilepsy. Warning, this video may potentially trigger seizures for people with photosensitive epilepsy. Viewer discretion is advised. This video is uploaded at 60 frames per second. So in order to see what I'm trying to show you, you have to watch it at 60 frames per second. Okay, here goes. Exciting. Okay, what you should have seen was a rainbow of colors.
I don't know whether you guys saw that. Did you guys see any flickering in the logo? Whatever she was showing, was there a flickering in your case? Did that logo flicker for you? You guys saw nothing. Was it a still? Did you see any flickering, or was it simply a logo that she demonstrated? Rainbow. The word rainbow was written. It was there. You couldn't see anything, but on my screen I could see it. Okay. Before this, when she showed that logo to you guys, this one, was this flickering? I'm asking you. Okay, but irrespective of what, my point is not that. My point is not here. Whether you saw it or not, it doesn't matter. My point is simple, okay? What matters is that she showed you something and you're instantly hooked onto the video, okay? A result is shown to you, or a surprising thing that'll make you watch the entire thing, okay? It basically, like, you start the class by showing something which shocks the people, but the whole class, they're trying to figure out what's happening. They don't know for sure what it is, but you just throw them ideas. It's not clickbait exactly. I know you couldn't make out anything, but my point is they try to do that. Okay. One more example of that is, I think, Up and Atom. She does it really well. Up and Atom, I think I spoke to Muralidhar about it today morning. She did it on information. Okay. This is about introduction to information theory, and look at the way she starts.
I dare you to try and read this sentence. Pause the screen if you have to. Did you get it? If English is your first language, you were probably able to figure it out pretty quickly.
Yeah. So you get it, right? So that creates the necessary requirement for the opening of the topic. It gives them an idea of where to follow. Okay. So it's like that part is the one that does the job really well, where it hooks you onto the video. Now, I want you to see Vsauce's video and continue it and see what he does. Listen to what he speaks next. We spoke about the weight of the internet. Now watch what he does next.
Of the entire internet.
Eating the strawberry, not so important for the video, but still it matters, okay? It is those little things that keep you there, okay?
What does that mean? I mean, the internet's a gigantic place, and how do you measure information? Well, let's start a little bit smaller with the Kindle. Right now, I'm reading Gatsby, which is a great novel that makes complete sense, except it was written without ever using the letter E, which is awesome. But when I put Gatsby on my Kindle, did my Kindle gain weight? Well, theoretically, okay. Yes, it did.
Why was Gatsby important here? Tell me. Was it even needed? But then the fact that it was written without using any letter E in the entire English language, entire novel written without using letter E, is something that you wanted to hear there. If you don't realize that, it is something you did not know about, and you were shocked. Okay, so that makes you hooked there. Okay, so these are the little things. So look at the amount of research he has done. He's connecting multiple topics. Okay, that's why I keep telling you the research part is important. You need to research a lot on what you're going to connect and what topics you're going to reach out on. So I don't know whether you see the whole time he's speaking about links.
It's because electrons charge floating gate transistors. And the thing about electrons is that they have mass. In fact, a professor at Berkeley estimated that when a Kindle is completely full of books, its weight increases by about 10 to the negative 18th.
He brought up some research, original research, and a low quality photograph of even a professor, no animation, nothing. It's just that it's there, okay? It's just there. But then he shows that there's some research done, okay? So the research element is very important. So I keep telling you research on the videos as much as possible. So whenever you come to a class also, I always have to read a lot for this reason. Okay. I know that half of you know about most of the things I teach, and it's pointless if I speak that. Okay. You will be snoring. Okay. And first of all, it's video internet classes. I can bet you'll snore. Okay. So it's like you need to come up with something more than what it is. Okay. So that matters. Then background setup. Now this is about filming. Okay. When you film, make sure you have a background that's either black or white or a fixed thing. Okay. Do not mess this part up as much as possible. Second, tools. What are next to you? Okay. For this, the best idea is, I think, what do you say? I don't know whether you looked at his video on Dong. Have you heard of the Dong video? Remember I showed you that lens law where he cooks. Remember that where he tries to cook a bunch of pins and whatnot. He takes something from the oven, electromagnet from the oven. Not so important, but still, he does it. Okay. So I think you guys have to learn lessons from these YouTubers a lot. Okay. We pick some ideas from each of them. It doesn't matter. Like, there are certain things. Okay. So please look into these things. Okay. Before you make the videos. About filming, look at the backgrounds. Okay. Make sure you have darker backgrounds and wait, I have optimized the clip. Yeah. I'm just trying to say backgrounds. Okay. You need a good, I understand the camera and filming matters. Now this is where CFL will help you. Don't worry about that. But make sure you use animation smartly. This is what I'm talking about. I think in this video, Physics Girl and both of them combined forces to make a video. But look at the level of animation they use.
In physics, entropy means the measure of chaos or disorder.
You don't have to use DSLR quality. We'll look into DSLR quality later. It matters. It matters a lot for winning. Okay, the DSLR part matters a lot. I'll show you now the winner of a breakthrough. If you remember, breakthrough, this thing. Winners. Let's see the difference. Okay, look at her, the way she starts. Look at the way she starts the video, and this is something I want you to see. Okay.
Exactly what number is this?
And a puzzle. Okay, it's like, I don't know whether I've optimized the clip, but if you can see that, yeah.
She says it's 6.
Okay, look at the DSLR
exactly
quality,
what number
matters. Okay, the background quality matters. It's a very good video quality.
Is this? She says it's 6.
This is a perfect.
She says it's 9.
So it's a blend of good animation at the same time documentary style. And she starts with a question that probably will, you know, get you into this thing. Yeah, she won for reference.
So who's right?
Yeah.
Actually, they're both right. They just saw it differently since they...
To be honest, she's not really great. She's struggling with language, we can see that, okay? She's struggling, but she's from Philippines, fine. We are fine with Indians doing it, so it wouldn't be that much of a problem. But she made a very good video, but look at the filming spots. She filmed it in different locations, relevant locations.
Sound is a wave. Waves from a moving source,
look at the way
like the car, get bunched.
Animation has been embedded into the actual video as much as possible. Okay, this is what documentary makers always do, usually. Okay, if you see Veritas's video, this is a format that's been followed.
Up in front and looser at the back. So for our case, those behind the car should hear the loose sound waves, a low pitch, while definitely many observers.
Then the car would be... But I know there's a lot of work gone into the animation part and a lot of softwares have been used. But my point is straightforward, that one. If you go with the breakthrough winner of 2019, he did a documentary format. Okay, he did it in a much more. It was exactly 3 minutes.
This is a neutrino.
Using the animation somewhere in between with the real video. Okay, so
you can't see or feel them, but every second each of us are bombarded by trillions.
Filming strategy with this thing. What this?
Of them. It's an elementary particle with no electric charge. And with
infographic could have done better. This font is horrible. Personal comment. That's all. Okay.
Almost zero mass. The average neutrino is less than 1/1,000,000th of the mass of the electron.
That's what I'm talking about. Okay, it's a perfect blend. Just trying to make sure.
It also has another name given it to by physicists, the ghost particle. Why? Because neutrinos only interact with the weak nuclear force and gravity, the weakest of the 4 fundamental forces. This allows them to travel through nearly everything unrestrained and in a straight line.
Using animation for those things, he cannot show things. Okay, so make sure animation is an add-on to things. Okay, it should make things better. That's all that matters here.
And their minuscule mass allows them to travel at nearly the speed of light. Antarctica detected a high-energy cosmic
here clearly. Okay.
neutrino that originated from 4 billion light years away. This neutrino came from a blazar, a supermassive black hole at the center of a distant galaxy, blasting high-energy jets directly towards Earth. The neutrino detection facility, dubbed IceCube, is a cubic kilometer of ice with thousands of sensors that detects neutrinos by relying...
I think you guys get the idea of a sound, to use animation with sound smartly.
And the tiny chance that a neutrino collides with the nucleus of an atom. When it does, the collision releases subatomic particles, which give off a glow known as Cherenkov radiation. This glow is detected by the sensors in IceCube. These findings invigorated a field known as neutrino astronomy. But why neutrino astronomy?
Why is it a train station? Now you'll get an idea.
Well, let's imagine a train. How do we know that the train is, say, moving? Well, that's easy. We see it, right? But light, a form of electromagnetic radiation, which is what astronomers traditionally use, has its limitations. For instance, something like fog could block or distort light. But if we focus, we can hear the train coming. We can feel the turbulence it creates in the air. Similar to how an incoming train carries information in the form of light, sound, and turbulence, the universe gives us messages in the forms of electromagnetic radiation and neutrinos, as well as cosmic rays and gravitational waves. Neutrino astronomy is simply a different way of seeing the universe. With it, we can look at high-energy cosmic events, gaze into the core of stars, and even look into the universe the moment after it began.
Now, some of you might ask, so this looks like a lot of work and a lot of animation, and Shashank, there are hundreds of people with equally good videos. What is the main criteria for selection? Now, for selection, I recommend you guys watch her video on how to win. She was part of the winner. She was a winner of 2017, and she made a good comprehensive videos on what it led to, like what are the things that they look into. Okay, she made videos on how to get that scholarship also, but you can check it out, how to make a winning entry. Okay, you can check out this video on your own. This is great. This is really good. You can check it out.
Hi, it's Larry, and as promised, I'm back with a video where I spill.
But now why this matters? Okay, one second. All of this matters. So one conclusive thing I need to draw to you guys.
Hi, it's...
1 second. What was I?
Exactly what number?
Physicists believe that for the...
Some of you might ask, where can I find videos? Where can I find... by the way, why does somebody require 2,500, 250,000, what is it? I think about $250,000 for college? USA. Okay, India, it's cheap, guys. Okay, go to US, you'll know how expensive college is. Okay, that's one thing. Now, with that being said, not Ivy Leagues, not just Ivy Leagues, even normal ones, student loans. That's a big problem in US. Anyways, with that being said, one second. I just need to discuss this. I'm losing track. Okay, some of you might ask, where can I get this thing from? What is that? The videos from? It's quite expensive, right? For that, I would recommend using Pexels. Okay, how many of you know about Pexels? I don't know. I use this a lot in my PowerPoint. So you saw my PowerPoint recently. It is filled with that. It gives you free videos on different aspects. Okay, free stock, high quality stock videos which you can use for free without any restrictions. Okay, so most of YouTubers use these things. Okay, most YouTubers use these things. Just make a documentary just by using these things. They're in the public domain, and you can use them without any attribution. Okay, I've used them a lot for the PPTs. I think you might have seen that plasma which I've used for my PowerPoint presentation. Those are taken from there. Okay, so please make sure you look into these Pexels. Okay, if you're interested, even for your PowerPoint presentation in the future, if you're doing it for a class, make sure you look into these things. Okay, there are many other open domains, but I think we can discuss regarding humor, which I think Nidhi mentioned. You can use humor. Okay, but it should be an add-on to what it should be relevant to what you're presenting. That matters a lot. For example, Electroboom, he makes himself part of it. Now, for example, I don't know whether you've seen Physics Girl or anybody does the videos. They are part of the experiment whenever they do something. Like there is that excitement, there is that, I don't know, you've seen Physics Girl videos when she does it. Okay, so I'm talking about that element. So if the humor actually adds to it, the way Physics Girl does it, that's a safe form of humor. Okay, I would recommend that as a safe form of humor. For example, I'll show you one more very particular thing. What is information by, I think if I'm not wrong, wait, Vsauce. I think Vsauce video that demonstrates something important of value. Okay, 1 second, Vsauce. if you remember what is not random, somewhere in between, Veritasium does something.
What will happen tomorrow?
Watch this part. You'll understand what I'm talking about.
Something contains.
By the way, how many, if you have pets,
You need to know.
you see an advantage of having pets now. Okay, observe this. Okay, have I shared the screen? Damn it. Have I shared it? No. 1 second. Yeah.
How random it is. And randomness is disorder, what we also call entropy. So information fundamentally is entropy. This makes sense if you consider a string of binary digits. For example, this string is perfectly ordered. It has very low entropy and it contains no information. That's the state of an erased hard drive. Now, this string contains slightly more information, but again, the regularities allow it to be easily compressed. So the string that contains the maximum amount of information is just a random set of zeros and
a random event in between the video. Okay. So it is not needed, but the cat catches your attention. Okay, it's something little, but it's like a judge might remember you for that. A judge might remember you for that. Okay, it's those little things that you put into the video will matter. Okay, it need not be a cat. I'm not saying it should be a cat. I'm saying it's that little thing, that smartness in the filming that comes in the filming aspect. Okay, you have to be very careful and come up with an idea for that. How you're going to write it down. Okay. So just make sure you understand these things. Okay. So also I recommend this guy, Minute Physics, how he does his videos, script and all this stuff. Once again, he shows a scripting timeline, so you'll get a rough idea of how much time, tips for creating. Yeah. So he just speaks about how he creates his videos, and you'll see that how much of work goes into it. Okay. So please look into this if you're interested. Yeah, I know. So you could have called it Schrodinger's cat. You could use a real cat in a Schrodinger's video, but put like no cats were actually harmed in it and show a happy cat face. Okay, so that might work. That might really work. But that kind of humor might work. So my point is that, okay, hope that clarifies things for most of you. So please make sure if you're trying to make a winning entry, just try to keep this at the back of your head. Not just for this thing. If you're making also a PowerPoint presentation in your class in the future, don't start boring. This is information. Don't start with the definition of information. Do not put too much text in this thing. Okay, have you seen the PowerPoint presentation where people put 100 lines of text inside one slide, which nobody reads? Do not do that. Don't be that person. Yeah, no one reads stuff anymore. It's just images and animation. Those are the things that matter. That's why I try to make sure my PPTs don't have any text. Sometimes I only have, I don't know, one photograph. One slide is one photograph, that's it. Look at that one word. Okay, make sure you understand, make sure you have a great background, make sure you have the word, make sure you communicate the point. Okay, so that's just something I have to tell you. Yeah, very important. Yeah, I know. So again, look, pixels. I chose pixels. This photograph was chosen from pixels. Okay, it's a single photograph, communicates my point. Oh, and one more thing, guys. People matter. Smiling face matter. People matter. I'll tell you why. Because I had I had to select from many things here, but I chose a video in which there is a person looking at a computer confused. Okay. The reason why I chose a person is that people relate to human beings very well in a photograph. If you put an abstract thing, people don't look at it. Okay. So for example, even in the next pic, this could have been my choice, but then this is a great picture, communicates my point, but there's no human being. He's looking away. It doesn't give you that effect. This one is more, what do you say, attractive for a reason. Okay. So that part matters. Here, stories don't, that doesn't matter. But here, there are human faces. You like the picture because there are human faces. And we humans are generally drawn to, that's why in banners, have you seen recent, all those banners on this thing? There's one model standing and 2 words. That's it. Done. That's an advertisement. There's nothing more. Okay. So make sure you try to stay with this thing. Okay. Just try to involve, if you're using those stock footage videos, which I told you, please make sure there are humans in it as much as possible. Not necessarily, but kind of matters. So yeah, that's it. I think that's about it. I just, yeah, Tom Scott, please check him out if you're interested also. Is whiteboard animation good? I don't know. Nidhi, you can comment on this. Is it good? You guys have used, how many of you use whiteboard animation? Murali, you tried whiteboard animation, right? If I'm not wrong. No? What is the software? There was some software we used. It's terrible, it seems. Whiteboard animation is terrible. Don't try it. Okay. Second thing, if you're doing, oh, by the way, if you're doing an experiment in your video, you have a higher chance of winning. I'll tell you why. I know most of you are doing very highly theoretical concepts and stuff like that. But if you're doing an actual experiment, that shows effort. Okay, additional effort to go and actually do it. Like, for example, how Physics Girl does her experiments. Like the train, she built a copper coil, this thing, track, out of a simple experiment. So that matters. Okay. So I don't know. You don't have to participate this year, guys. Some of you might participate next year. You could plan a good one next year, is what I'm trying to say. Build it over time. Write a script for a month. That's what I'm trying to say here. Okay. What about audio? Recording, that we can look into later. Studio and all. The studio for that and all that stuff. Okay. So yeah, make sure you try to involve as many elements like this as possible. So even when you're doing a presentation, even in a class. Okay, cool. Any questions? I think I'll take it during the break. So the format this works is I'll give you a break exactly at 5:45. Okay, exactly at 5:45, a 5-minute break. So remind me quickly. I think Murali's video scribe, we'll look into it. Yeah. Yeah. Okay, that's fine. Now, just need to go back to our old stuff. There's no grading period. I know about that issue. Yeah. Is there a quiz today? Yes, you'll have a quiz today. I can't let you go today without giving you some torture. That'll be too, so not me. Okay. There are no 2 classes. There's a single class, guys. There's a single class. You'll have to bear with me. 2 hours of mathematics. Good luck. Continuously. What is the most appropriate topic for the challenge? There are many. You'll have to pick. So I don't know. There are multiple. I told you your comfort zone matters. But make sure you have a question in the beginning that gets them hooked onto the topic. Okay. Make sure you catch them early on. Okay. I just want to talk about what we were discussing and just go ahead. Coronavirus is trending, but if you tell them something about the coronavirus they don't know about in the beginning, they'll get hooked on to it. If you tell about, not about the coronavirus, it could be about some virus back in the day that took down some elephant, an entire species of mammals. You could speak about something that's not relevant today also, doesn't matter. Okay, you could start with something that surprises them. But, okay, took down, maybe it affected dinosaurs. There was a virus that affected dinosaurs. Okay, or there might be a weird fact about viruses that nobody knows about. Okay, usually nobody knows about. And you pick it up and just make it, put it out there, put it out there. Okay, yeah. Can I create fake news? No, don't do that. Okay, with that being said, don't be Trump. Okay. Can we create fake facts? No, obviously. Okay. Anyways, with that being said, on that stupid note, wait a second. Trying to go ahead with the presentation is an issue. Okay. So here's the thing. We covered a lot. We covered a lot in complex numbers, except for killing Amitabh Bachchan. Good reference. How about science? File the video for type of videos. I don't know. I've not checked out the format, so look into it. By the way, documentary format, keep that at the back of your head slightly. Okay. Yeah. Now, with that being said, let's go ahead. Go ahead. Okay. Okay. So we discussed this. We finished this. We had this thing done. Was this done? Multiplication part? Can I get a yes on that, guys? Yeah. Good. Complex plane. Did we speak about the complex plane? Did we discuss this complex plane? Did we discuss addition, subtraction? Yeah, I think we discussed magnitude and argument. Yeah. Does anybody have doubts about argument and stuff like that? Is this clear? The argument part? Argument part, is this clear? Okay, cool. So here's a bunch of things, okay? What is subtraction? Just subtract 2 complex numbers as they are. Okay, nothing much there. Okay, anyways, with that being said, multiplying complex numbers. Now, when you multiply complex numbers, try multiplying this, okay? I'll give you 3 numbers. One is 4 plus 3i, and you're supposed to multiply to I. What will you get? Tell me. Come on. Try it, come on. Multiply 4 plus 3i into 0 plus 1i. What do you get? Shashank, I know you know that. Okay. What is it? Come on. Yeah, Sakshi, you're right. Ketan, you're right. Wait, am I wrong here? Yeah. No. Srijan, that's right. Wait. Navya, that's, wait. I'm confused. 1 second. Nah, okay. Medansh, you're right. Shraddha, you're right. Some of you are just writing it as it is. Okay. But do you agree it's minus 3 plus 4i? Hope you agree with that. I square is minus 1. Okay, I square is minus 1. But I square minus 1 comes here. This is the location of minus 3 plus 4i. But do you observe something very interesting? I think Shashank knows about it. Shashank V, not MN, I'm talking about. But can you tell me what's so special? What's something that you can observe? If you look at this angle, it's 36. This angle is 90, and this angle is 126. Yeah, what happened? Yeah, Sakshi, you're right. The angles got added up. Okay. The surprising thing is the arguments got added up. In simpler sense, if you have a complex number A and a complex number B, and if you multiply them out and you get a complex number C, then the surprising part is the argument of A plus the argument of B is equal to the argument of C. Or, in other words, if this is I and this is minus 4 plus 3i, then this is 36 degrees, 36 point something degrees plus 90 degrees, giving you 126 point something. So arguments get added up. Is this fine? The arguments always get added up when you multiply. So basically, one more way of looking at it is this 90-degree rotation number rotated this vector by 90 degrees. Can you see that? It got rotated by 90 degrees. It was here, it went there, exactly by 90 degrees. Okay, so that is one thing that adds up. One thing that happens. Okay, so whenever you multiply to complex number, the arguments get added up. Okay, now you see why this was more common sense to think of I as a rotation by 90 degrees. It started making sense finally. Okay, it does it to anything you multiply. If you consider complex numbers for vectors, does multiplication not hold good? For vectors, it doesn't. For complex numbers, it does. Complex numbers have much more interesting properties than vectors. Yeah. What is the cash prize in Indian rupees? Can anyone convert it for her? Okay, breakthrough challenge cash prize. I'm too lazy to do it right now. Yeah. Anyways, what was the background music going on? I don't know. Okay, around 2 crores. Yeah, 2 crores. Roughly about 2 crores. The cash prize for the breakthrough challenge. Yeah. Now, anyways, with that being said, I think that's my sister playing piano in the other room. Okay, sorry. Okay. Anyways, with that being said, if you multiply 4 plus 3i into 0 plus 1i, you get this thing. This example was done. You can try it with other things. You can try it with 2 multiplied with 3 plus 4i gives you 6 plus 8i. And if you observe, the angle again gets added up. Okay. Yeah. With that being said, even I into I gives you minus 1, which has an argument of 180 degree. Hope you agree with that. What's the argument of I, guys? Argument of minus 1? What's the argument of minus 1? Can anyone tell me? Argument of 1, you know. What's the argument of minus 1? It's on the other side. It's actually pi or 180 degrees. Is that fine? I think that's clear. So, okay, good. Anish, like, if I win this challenge, I'll buy you a Nokia phone. Thank you. Okay, thank you for the concern. Anyways, with that being said, I have a Nokia phone. Okay, fun fact. Okay, anyways, with that being said, going ahead, so I think this must be clear. Arguments get up. But what about modulus? What about the modulus? The teacher gets half the money, it seems. No, not 1 crore, some 50 or something. That'll go to, I think, your science teacher from your school, whoever it is. He or she will get it. Okay. But make sure you name the right science teacher there. Okay. If you have 2 teachers, make sure you name the right one so that both of them don't get angry at you. Okay, that you didn't name me, you named the other one. Okay, so I don't know. Pick the right teacher in your school. Okay, when you do that. Yeah. I'm not sure how that is. Okay. Now, yeah, you have to choose between 3 teachers. Good luck. Okay. Anyways. With that being said, you need to know the magnitude. So the magnitude is, surprisingly what magnitude is, magnitudes get multiplied. So the lengths get multiplied. The lengths get multiplied. For example, if you have, let's say, the length of this complex number is 5, right? Okay, this is 1. Okay, and surprisingly, the magnitude of the answer is 5. And you can observe the same thing with all the other complex numbers. Okay, when you multiply, the magnitudes get multiplied, like 5 into 2 is 10. Is this fine? Got this logic? I'm just saying the magnitude, the length of the complex number get multiplied. The final one will be the same. Okay. Murali says, what if you are self-taught? Then don't name anybody. That's better. I don't know if that's a provision, but yeah. Is there a deeper reason? What? Deeper reason? Yeah, I'll come to the deep reasons later. Okay, fine. With that being said, by the way, if you do win, make sure you use it as a scholarship. Use it as a stepping stone to get into MIT and all. Okay, because that's a big, very important thing on your resume. Yeah. So yeah, I'm showing the previous slide. Yeah, this is the previous slide. Okay, now I'm hitting the piano. It could have been a little bit more silent. But I can say that argument is minus 180 for 80. They can coincide in both different editions. Which should I pick? I'll come to that, Shashank. 1 second. He's asking the argument of this thing can be 180 degrees for minus 1. The argument can be minus 1, but it can also be minus 180 degrees. You can go the other way, right? Hope you guys got the logic. Instead of going this way, you could have gone the other way, minus 180. So argument can be also minus 180 for the same thing. Is that fine? Okay. Murali prefers the piano rather than my voice, it seems. And no offense, of course. Yeah, I understand. No offense, of course. Yeah. Anyways, with that being said by Murali, we'll continue on. And here we have a situation where this summarizes whatever I just told. Z times W gives you this combination. Okay. If you want to remember it, if you have two complex numbers, A plus ID and C plus ID and stuff like that, the moduli get multiplied, the arguments get added. Simple. Do not forget this. One more thing. Will the winner only get the prize or others also get it? Remember, everybody gets some prize or the other because there are multiple prizes. Okay, it's not just that main prize, and there are multiple little prizes which they get. I think there are, so you might at least get to meet a bunch of scientists if you get to go to the ceremony. Okay. Okay. Anyways, on that sweet note, okay. Okay, good for you guys. Okay. With that being said, I just need to skip this bit, not so important. What does multiplication by minus 1 do? Tell me. If you multiply anything by minus 1, what should it do? Tell me. Now that you know that arguments get added up, what is the argument of this thing? What is the argument of minus 1? Nothing is there. What is the argument of minus 1? Tell me. 180 degrees. So if you multiply, let's say if I have something at 36 degrees, if I have a vector exactly at 36 degrees, and if I multiply it by minus 1, some complex number which has the argument of this thing, and I multiply it by 180 degrees, what will I get ultimately? Or let's say, I don't know, 180 degrees, yeah. Something of 20 degrees, let's go with 20 degrees. Do you agree I'll have something of 200? Something of 200 degrees? It's as if, do you see multiplication by minus 1 actually rotates? If I have 4 minus 3i, and if I multiply by minus 1, I go there. You can think about it as a flip that happens along the 0. But you can also think of it as if it rotates something by 180 degrees. Do you agree with this? If I multiply by minus 1, I'll get minus 4 plus 3i. Hope you agree with that. That is common sense. But it's always a rotation. So whenever you multiply by minus 1 in your life for now, keep this at the back of your head. Somewhere there's a rotation happening without your logic. Okay. I'll ask you a simple question. What about sine x? If I multiply by minus 1, I think I told you this earlier. If I have a wave function, like a wave like this, if I multiply by minus 1, what will I get? I'll get exact mirror image of that, right? Yeah. Now, what if I told you this is actually a rotation about this axis? This is what happened. Yeah, now the complex plane makes sense to you, right? Why? So when you multiply by minus 1, okay, actually this thing got flipped, not flipped exactly, rotated. So you can now imagine what I sine theta will be. I sin x will be. Okay, you can start to visualize as if this wave is rotating about this axis, x-axis. Something like that. Something like that. Okay, we take advantage of this in physics sometimes. Okay, I think sin x into -1 is cos x. No, 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 no. No. X to the power I. Oh, we'll come to that. We have I to the power I. According to the graph, no, it doesn't. It doesn't. This is not sin. This is not cos x. Don't tell anybody that's cos x. I'll jump out of the window. Please don't. Yeah. Okay. Okay. Now, how many of you have heard about this complex conjugate concept? Yeah, there's something called complex conjugate. The way it works is, this is simple, guys. Complex conjugate is replace wherever you see an I with -I, and everybody's happy. That's complex conjugate. Wherever you see an I, replace it with a -I. Okay. Now, I'll give an example. Okay. For example, we have Anvita. What is the complex conjugate of this? Tell me. Minus Anvita. Okay. Because I gets replaced with -I. Is that fine? Yeah. Some of you ruined their name, guys. It's not Anvira or with. Oh my God. Okay, fine. Anyways, no offense, Anvita. Now, anyways, with that being said, there's one more example. There is, I think we can go with Nidhi. Sorry, Nidhi. What happens to the conjugate of this? What do you get when you take conjugate of Nidhi? We had a Nidhi in the other batch also, so we could use it really effectively. It becomes the same thing, not anti-Nidhi. It just becomes Nidhi itself. Because there are two I's. Okay, this becomes minus, this becomes minus. Minus into minus plus, so you get Nidhi. So conjugation operation doesn't change Nidhi. She remains the same. Is that fine? We can try this others also. Prajwal remains the same. Yeah, Prajwal, oh, by the way, if you try in Prajwal, that also works. Take conjugate on this, nothing. Prajwal, same thing. Okay, got the logic? Yeah. I think Sai Pratiksha has a lengthy name. Okay, so that'll be a complicated one. It'll work. Sai Pratiksha will work. Who else? Tell Satvik. Satvik will work. Yeah. Wait. Satvik, where's Satvik? I can't see Satvik. Satvik. Yeah, okay. Somebody wants to compliment you. A compliment came which said nice collar. I don't know why. Okay. With that being said, use. Oh no, that's too lengthy. Okay. Thank God you got my spelling right. Okay. And I know it's W. Okay. Now, with that being said, let's go ahead. For example, if you have 4 plus 3i, replace it with -I. What do you get? Tell me. Quickly. It's very easy. I think Sai Pratiksha is trying to join from her school ID. Okay, this will give us exactly how much? Oh my God, I don't know why is my PPT stuck. Yeah, so you get 4 minus 3i. Okay, 4 minus 3i. Is this fine? Okay, what happened? Was it a rotation? Was it a flip? What happened? What do you think happened when you took a conjugate? When you take a conjugate of a complex number, what do you think happens? Some of you are thinking of mirrors, some of you are thinking of 90 degrees, some of you are thinking, oh, 4 remains as it is. 4 remains as it is. Just I gets -1, that's all. I becomes -I. That's all that changed. I didn't get rid of the imaginary part. The imaginary part is there. Ah, yeah, Sakshi, you're right. Yeah, what about 2 minus 2i? What about this? Yeah, I know my number lines are horrible. I'm sorry. Okay, tell me now. What happened here? 2 minus 2i. What is it? 2 plus 2i, the conjugate. Okay, now I think it should make it much more clear that it's actually a reflection about this terribly drawn axis. Is it fine? It's a reflection about that. It's a mirror image, or in some sense. So conjugation flips something about the real axis. What if a complex number is purely real? What if it's a real number? What will happen? What will happen when you take conjugate? It's like Nidhi, right? It stays as it is. Or like if you do it on Prajwal or I don't know, Murali, they're not working, Amit, Shushruth. If you try it on Shushruth, it works. Okay. You can write on Shraddha. Same thing. Shraddha is more real number like this. Say you take the conjugation operation, it remains where it is. Doesn't want to go anywhere. There's no I there. Okay. Fine with this. So now what's the definition of a real number, guys? How do you define a real number now? A real number is a complex number which is equal to its conjugate. Now we are starting to define real numbers for the first time. Okay. Yeah. So so the idea is it's not there. So if a number is equal to its conjugate, we say it's purely real. Okay. For example, 4 plus 0i, its conjugate is 4. If you take a conjugate is usually a bar at the top, which gives you 4 plus 0i only, 4 minus 0i, but it's the same thing. It's equal to 4. So in that case, yes, check. Yeah. Flips about how much? Flips about the axis, this axis. If it's on the x-axis, it doesn't know much. On the real axis, sorry, real axis. Okay. Now, one more thing. If you have two complex numbers, z and z bar, this is z bar, which is x minus iy. What happens when I add them? What do I get when I add them? Tell me. Or you could subtract them, whatever. Agree, you get 2iy. This time I've subtracted. Subtraction gives you 2iy. Is this fine? Okay. Now, interestingly, if I were to take that and then divide it perfectly, if I take this side and divide by 2i, I'll get y, right? Can I get yes or no? That part is clear. Yeah, the funny thing is, if you want to get the imaginary part of a complex number, all you got to do is take z, subtract it from z bar and divide by 2i. Then you would ask, is this a joke? I mean, look, when I look at 3 plus 2, I know this is imaginary part. Why do I have to do this stupid thing where I have to use this formula to get 3? Okay, yeah, Murali is like, kuch bhi. Why? Yeah. Yeah, Pratish is sitting and calculating money, guys. She's like, I can buy 200 iPhone 11s out from the contest money. Come on. Is this what you're doing? Okay. Anyways. Oh my God, I'm scared. Okay. Anyways, complex numbers. Yeah. Anyways, so can't believe that happened. Anyways, z minus z bar by 2i. Okay. So yeah, this works. This gives you the imaginary part. What about the real part? This is messed up by me. I'm murdering y. X is z plus z bar by 2. Is that fine? Common sense, right? That makes sense. If you do z plus z bar, you get x plus iy and plus x minus iy. Iy gets cancelled, you get 2x. Is this fine? Clear with this? Oh my God, okay. What is the application of this? Why do you need this? Okay, just saying it's about conjugate operations, the basics of it. Okay, you'll get an idea of why I'm discussing this in some time. I'm using z, by the way. In normal algebra, you used to use x, right? You used to use x. If you remember, you used to use x. Now we use z for complex numbers. Z is used, not z axis. It's simply use z. I'm sure this is a mystery. Boom will just make complex. No, nothing. Imaginary part of z. Imaginary part of z. Is this fine? Im is imaginary part. Yeah. Z is not integer here. Z is a complex number. We use Z symbol for that. Okay. I'm sorry if it's too much. Listen to this. One more thing. This is a visualization of what happens when you take the complex number. So when you add both, sorry, this is x, okay. When you add a complex number to its conjugate, you're actually getting it on the real line. Okay. I think now you can visualize and see why it always gives you the real part of it. Yeah, I know you didn't realize why it's useful. Give me some time. I'll explain why. Oh my God, I can't erase things. Come on. Can't erase blood. Okay, fine. Anyways, but the idea is when you add both of them, you get 4 plus 0i, and then when you divide by 2, the vector gets shrunk. Okay, so when you think about vectors, this gives you a better idea, is my point. Got this logic? If you think in terms of vectors, this formula really makes sense. Oh, basically what I'm saying is x is equal to x part of an imaginary number is z plus z bar divided by 2. Just divided by 2. And from a vector point of view, that makes more sense. You think imaginary part is a fraction according to the equation. No, imagine number can be a fraction. Who said it can't be a fraction? You can have 3 by 2i plus 4 by 2. I don't know. That's the imagine number. Why 4 plus 2i is not 2? I plotted 2 plus 0i. I can't erase this. Damn it. It's 2 plus 0i there. Okay, I'm sorry. Okay, I is not at the bottom. Okay, now I won't do this part because it's not so useful for you guys. I'm just going to skip this part, this set of the problems. Can imaginary numbers be irrational? Imaginary number can have irrational numbers like root 2 plus root 3i, or you can have root 2 plus, I don't know, 5i. Done. Yeah, maybe Mithil. Some scars are meant to live for. You can't erase all memories, Prajwal. Okay, good. Thank you. Some scars are meant for life. Okay. How is 4 plus 0i divided by 2 equal to 2? It will be 4 by 2 plus 0 by 2 I is equal to 2 plus 0 by 2 I. That is 2i. 2. Done. Fine, right? Okay. Okay, so I'll just skip this part. This is an important lesson, but then I'll just figure it out later. One more thing. Always z bar has negative argument of the whatever argument z add. For example, if this was 45 degrees, this will be minus 45. Is this fine? Just an idea. Something that should common when you look at it, should make sense. Okay, so from now on, what's going to happen is I'm going to sweep through the topic. Okay, certain topics are not so important for you guys. I'm just going to sweep through it. Okay, fun fact, z into z bar, then what do you think z into z bar is? Can you take a guess of when you multiply something to its conjugate, what do you get? 4 plus 3i multiplied by 4 minus 3i. Yeah, okay. This is too much, I'm really sorry. But fun fact, do you agree it's going to be real and positive? I don't know whether you realize it's going to be real and positive because I'm multiplying something 45 degrees into minus 45. Do you see the argument of whatever answer I get to be 0 degrees? Got that logic? Whatever I multiply, the argument of this will be 45, but the other one will have negative 45. So the result will have an argument of 0. So I know it will lie on this positive axis, positive real axis. For sure, I know this answer is going to be positive and real. Got it? Now some of you are confused, like, what about 2 power I? I'll come to that. There's a rectangular form for that. I'm not yet there. Okay. No, all I'm trying to say is, when you multiply z into z bar, the argument of the first one could be 45 degrees. The second one will have minus 45 degrees, whatever, as an example. But I know that when you multiply two complex numbers, the arguments get added up. If it is 26 degrees and 180 degrees, they get added up, giving you 200 and 206 degrees. The angles get added up. So if the angles get added up, if the first one has 45 degrees, second one has an angle of minus 45, then both of them add should give me an angle of 0 degrees, which means I know that whatever complex number, that answer I'm going to get out of this is going to lie on the positive real axis, which has an argument of 0. Is this fine? Angle of 0 degrees, whatever it is. Four plus 3i and its conjugate. No, it will work, still work. Yeah, why not negative? I'll come to that. Why not negative? Some of you are asking. Ta-da! X square plus y square will give you always a positive number. X square plus y square will always give you a positive number, no matter what. And by the way, some of you messed up this I square. Okay, so you land up with mod z the whole square. This is modulus z, right? Yeah, so my point is z into z bar is mod z the whole square. It's a length of z the whole square, whatever the length of z is. The square root of this thing, that is the whole square. Okay. I don't know, Mithil. Okay, is this fine, guys? Got this bit? Yeah. Okay. Others. Okay. One more thing. Just do me a favor. Go for a break, guys. I know it's not 7:45. Come back in next. I know you guys need a break. 5 minutes. Throw some water at your face, or a hose, or a pipe, whatever. Just come back in some time. Yeah. Is there any way to make it intuitive? Yeah, there are ways to make things intuitive. I told you, right? W into W z bar, when you multiply, things can go down. You can tone it down. Okay. Others, just take a break. Okay, Murali, what is that? Tell me. The way I see it. Okay, there is some interpretation. You can always interpret these things. I'm not saying you can't interpret. It's going to be a positive number, I guarantee you. The way we see the number I, okay. How is x square plus y square is equal to mod z square? Because z, mod z, we had studied, mod z is equal to square root of x square plus y square. Remember this? If you add a 3 plus 4i, the modulus of that was square root of 3 square plus 4 square. Similarly, x plus iy, its modulus will be square root of x square plus y square. Okay, that leads you to say that mod z the whole square should be equal to x square plus y square. If the complex number is x plus iy. If the complex number is x plus iy. Electromagnetic induction DPP or no DPP for this chapter. I don't know what to give as DPP. Okay, Shashank V is asking me from that time for 2 power I. What is 2 power I? I'll come to that. First of all, tell me what is I power I? Somebody. Or I power I. That'll be fun. Okay, cool, Vivek. Okay. Math error? Okay, some of you are trying it on calculus, that's why you're getting math error. You're not able to see the mistakes. Okay, 1 second. Can only see the scores. 1 second. I think there's an issue. Some of you are thinking why it's going to be that way. 1 second. I think it's fine, Murali. You can do that. Welch Labs video, 1 second. Welch Labs video using Python was amazing. Yeah, that's amazing, I know. Can you multiply the number by root of -1? Yeah, you can. I power I to the power I is 1 by I. Wait, I have to think. I is equal minus I minus 5 by 2 minus I. Yes, it's 1 by I, Nidhi, yes. I, good one. I power I is 1 by I. Surprisingly 1 by I. Is it 1 by I? Yeah, it is, right? Yeah, it is. Okay, Vivek, cool. I power -1 is 1 by I. I power -1 is 1 by I. Which is equal to minus I, by the way. 1 by I is equal to minus I, yeah. 1 by I is equal to minus I. Those of you don't know, I think 1 second, Satvika, this is taking me time. Before that, 1 by I, if you have 1 by I, that's equal to minus I. You can try this out. I power I simplifies to minus root of -1, root of, yeah. Something like this. There's a reason for that. Wait, did I mess it up? Yeah, that's correct. It's I. This one. I power I is, how is 1 by I minus I? Okay, that is tricky to explain, but we can do it. What I'm going to do is 1 by I, I'm going to multiply numerator and denominator by I. Okay. So when I do that, this is called rationalization. You might have studied it before. You multiply I into I, something like rationalization, but something like that, not exactly that. So when you multiply it, I square becomes -1 in the denominator. Numerator becomes I. What is that? Gives you still minus I. Done. Okay. Cool. I'm actually jumping a little because, yeah, I hope this is clear. So I power I is ith root of something. I know it doesn't help. Wait. I'll come to that. I to the power I is, I won't tell you now. I know what it is. I won't tell you now. I'm coming to that. It'll take some time to realize that. No, it's not -1. Yeah, I to the power I is about 0.2. Yeah, roughly about 0.2. You're right. Return information, probability to things, less formula information just because of the formula. Just because of the formula. Not because of the formula, it makes sense. If I have, let's say, I'm trying to figure out something. I'll give an example. So let's say I have, oh my God. Let's say you're trying to figure out, there are 4 letters, A, B, C, D, E, F. No, 4, no, I want more. G, H, I think 8 are enough. Okay, so I have 8 letters.
Sir.
I'll pick one of these letters. Okay, you're supposed to figure out, only asking me yes or no questions.
Sir,
Yes
sir.
/ no questions. Which one is in my head?
Sir.
I'll give you exactly 2 questions. You have to figure it out in 2 questions. I'm going to answer only yes or no.
No,
Did you
actually,
follow my induction? No, there won't be one.
sir, actually, I got this part. I'm like,
Same like the quiz. It is something like the quiz. Best free editing software, I have no idea. I think OpenShot is a famous one, free one. Then there's Windows Movie Maker. Both are great, but DaVinci is there, I know, but it's okay, I guess. Yeah, okay. Anyways, DaVinci Resolve, yeah. It's amazing, I know. But the thing is, I would prefer Premiere Pro, whatever it is, any day, combined with After Effects. Okay, listen to this. You
Hello,
guys
sir.
have, I'm thinking of one of these alphabets. You have exactly, you can turn on the microphones. I'll give you the permission.
okay,
This
fine.
is a
Actually,
short course on information
Sir.
theory. Okay, tell me, which letter have I picked in my head? You have 2 questions to ask, no more than that.
F.
What? Are you guys sending me something? Are you guys even talking?
hello, sir. Mic check.
What? Seriously? Nobody's. Somebody's asking which letter are you thinking? Dude, I told yes or no. Can answer only yes or no.
Is it the first 4?
Is it A, B, C, D? Keithan asked, is it A, B, C, D? No. Yeah, 1 question down. He asked, is it A, B, C, D? 1 question down. How many questions are you going to need for this? Tell me. Vivek is asking, is it E, F, G, H?
Is the letter
That is a
before
stupid question.
FG?
If it's not A, B, C, D, it's going to be F, G, H. Why are you asking that? Okay, I've told you it's not A, B, C, D. Yes, I told no for that. He asked, is it A, B, C, D? I said no. Satvik, last 1 question. Okay, I'll give you 2 questions. 2 questions left. 1 is done, 2 more questions. Quickly. 2 questions left. Satvik asks, is it E, F, G? I'll go with that. Yes, it's among E, F, G. Last question. Wait, you need to ask, is it? I need a is it question. Is it letter F? Okay. No. Done. So I've given you all the information that you need. Now you are still lost because you don't know whether it is either G or F. It could be G or F. You guys have no idea still. Okay. But I gave you 3 chances to ask yes or no questions, or 3 bits of information where I answered you no, yes, no. Okay. I answered you 3 things there. But the point is, you could have actually figured it out with just 3 bits. You could have figured it out. This was 0, 0, 0. So 0, 0, 1. This was 0, 1, 0. This was 0, 1, 1. This was 1, 0, 0, and so on. You could have actually, I was actually thinking of G. You guys are right. But if you look at it, I don't know, this is a fully information theory class. If I take up a class in BSc, just doing a gist of it here, you require a maximum of 3 questions to figure it out. You don't require more than 3 questions. Okay. If there were more than, let's say, 8 possible, because it's 2 power 8, 2 power 3 is 8. It's sufficient. 3 questions are sufficient to span a space of 8 possibilities. If you had 512 possibilities, you require 2 power 9 questions. So 9 questions are sufficient to figure it out. Okay. So if I tell you I'm thinking of some Bollywood actor, that's probably a space of 512 actors maybe. And with 9 questions, I can figure out who that actor you're thinking about. Just ask me 9 questions. Not less than that, not more. Yeah, why it's Amitabh Bachchan? Yeah. So, yeah. So I could be thinking of some actor. And I know I'm not thinking of Sushant right now. I'm sorry. Yeah. But yeah. So you could start with easy rich. That's not a great question to ask because all of them are rich almost. Okay. Yeah. Yeah. So I sent it in the morning to Murali. The question was, which contains more information? If I told you Sushant is dead, or if I said Amitabh Bachchan is dead, no offense to Amitabh Bachchan fans, but if I said one of these two today to you, which one would give you the highest amount of information to your head, surprise to your head? Both will give you surprise, but which one more? Obviously Sushant one, right? Because he was young. And second thing, it was a very less chance of that happening. So any event, any statement that tells you about a low probability event, low chance event, contains more information. So for example, if I were to tell you sun rises in the west today, now that's a lot of information in one sentence, because that is something you don't expect. If I tell you sun rises in the east, that statement doesn't contain any information in it, almost zero. Okay, I didn't say it's true. I just said that contains less information. Okay. So that's the brief this thing of information theory. By the way, done. Okay. With that being said, I missed your message, Shashank. There was a stream of messages. Everybody back? Can we start? Guys, can we start? Can you turn on your webcams? I have no idea. Okay. Murali says Sushant was a medalist in physics Olympiad at the national level. Nice. Okay. What else? 7th rank in India. I heard about that. Yeah. He's an IIT. Yeah. I don't know which IIT, but depends, I guess. He has a degree from Stanford. Now that makes sense. That is what IITs give you, a chance to go to Stanford. Unless you go to Stanford before everybody pushes you there. Like you go in the beginning itself. I don't know, after finish your PU itself, not PU, sorry, for your immediately directly apply. Get it? That's great. Yeah. By the way, fun fact, guys, not all IITs are great. Half of them suck. Okay. You might as well do it in a local engineering college. Yeah. Yeah. Okay. NITK is great? No. No. NITK is okay. Okay. The word is okay. Ask people. Okay. It's okay. It depends on which department you're talking about. You're going to chemistry? Maybe. Mechanical? Maybe. So there are a lot of maybes there. So when you say some place is great, it's great for a particular thing. It's good for a particular thing. Others, it sucks. So always remember this. Always remember, they say UC Berkeley in US is known for PhDs. And this thing, which is that MIT is known for pure sciences and more of that. So always keep that at the back of your head. What is greater? There are many. I've asked this question 4 times. Is there a geometric interpretation of exponents? Why 2 power 3 being... yeah, I'll come to that sometime. Okay. Yeah, Cambridge is known for arts. If you're going to arts and if you're interested in literature, I think I lost internet. Okay, if you're into arts and if you love art and whatever, Cambridge is great. Yeah, even France. France is known for art-like things. It's awesome. It's heaven for those of you who like arts. you guys can hear me, I'm sorry I lost my internet for a second there. Yeah, okay, I'm back. Okay, we'll get started. Can you guys turn on your webcams? I know that was accidental. I lost my name. I was just saying code word Bangude. Happy? Okay. Yeah, done. So yeah, France and all are known for arts right now. They've moved away from science and they do mostly art nowadays. Okay, if you're into art and whatnot, it's great. In India, for arts, I think Ashoka University is great. Awesome. I did my master's at Mangalore University, but before that I was at Aloysius. Aloysius is great. It's good. It's okay. It's okay. It's not great. Okay, if you're getting into. And sadly, there was nobody to tell us at your age. Okay, go do good stuff. We landed in stupid places. Thanks to that. Okay. What is the best in Mangalore? I have no idea. Depends on the. Okay. Before that, now some of you might ask, what's the use of conjugate? Quantum mechanics. Ta-da. Okay, if you look at this xi squared here, which you see, is actually complex conjugate. Okay, it's actually xi times xi bar. What you see here. So when we get this chance of where the electron is highest to be found, the orbitals that you see, whatever, that's actually this xi square. Okay. What is z? Xi. I don't know. This is what the wave function looks like. It has some complex and imaginary parts, but when you square it, you get that. When we get the dpp of electromagnetic induction, there won't be a dpp for electromagnetic induction. I can't see the screen. Can you guys see the screen? Okay, others can. I'm sorry. Okay. What will we give for the test? I don't know. Okay. Fun fact, I just wanted to add something as a fun bit. What else is imaginary? So people, whenever they come up to this topic and they say that complex numbers are super imaginary and all that stuff, yeah, they say all this stuff that, people keep asking. Even Balki, one of the reputed professors from IIT Madras. Oh, by the way, IIT Madras is awesome, okay, for physics. Now, with that being said, computer science, I don't know. You need to contact somebody into computer science for that. Now, with that being said, people ask, what is the meaning of I in complex numbers? It doesn't make sense for many people. Okay, but when you think about it, what else is imaginary? I just wanted to add this is something I just wanted to add. Most of the things that you know of are imaginary. Is money imaginary? I see the best for physics in India. No. IIT Madras will still beat it, and Delhi University ranks the top at everything at physics. Okay, nothing beats it. Anyways, yeah, dreams are imaginary, but money is actually imaginary, guys. It's a concept in your head. You think that coin has some value, so everybody thinks that has, that sheet of paper that you have in your pockets. I mean, you don't have, unless you have some pocket money, but that paper it's just a piece of paper, right? Unless people believe that, that thing has this thing. Yeah. NITK is in 13th place in this country. That tells you how bad the country's education is. Okay, NITK is in the 13th place, you told me. Okay, just giving a rough idea. Okay, which is the best for medical? I have no idea. You just need to talk to someone who does medical. Okay, so money is imaginary, but you don't keep seeming to ask me questions such as why is, So my point is, you have a bunch of imaginary concepts in your head. Okay, at the end of the day, it's not just I or something. It's not a big deal. It's just a concept at the end of the day. Okay, yeah. Time is imaginary. Yeah, okay. Time is imaginary. Time could be imaginary. We don't know, but it's a real thing. We feel it. It's a tangible thing, at least. Okay, it's a tangible. We feel it, right? Like I experience it. These things I experience. I wanted to add one more thing. What about religion? That's been put in your head, right? Since childhood, fictional concept. It's been said that we humans are the only ones who believe in fictional things. Okay, things that don't have to exist. Like for example, does the country India exist? Does a nation exist? Really exist? It doesn't exist actually. It's in your head. You think there is a country out there that exists, and you think like, okay. It's actually an imaginary thing when you think about it. Really, think about it deeply. It's an imaginary concept. We all believe that there is a nation called, I don't know, US, and a group of people living there, and a bunch of boundaries. So you think it's a real thing. Okay. Stereotypes, yeah, castes, and most of the things. Yeah. One more funny thing that's been put in your head, and I hate this is something I wanted to address, which is going on in US now. George Floyd, yeah. Uh, the very idea. I think that's been put in our heads a lot. I don't know how much, unless you had great parenting. This has been put in your head that, Black lives. I think Indians are racist. Do you agree on that? I don't know. But Indians are racist. That is something I've realized. Particularly family, relatives, they have this idea in their head that black is bad for some reason. Okay. People have it. People have it. Yeah. It's so stupid. Okay. It's there. I don't know, since childhood, those Fair and Lovely advertisements? Yeah. It's in our heads, no matter what. It's just there in our heads, okay, for some reason. Yeah. What if time is what we feel as increasing entropy and time is illusion? Maybe there's a theory like that. I know that. Yeah. One more thing I got to add: stereotypes. As who told me? I think Anika told me. Like, for example, you have the stereotypes, right? Like, for example, that gender is, yeah, gender. But stereotypes, for example, all of you guys here, all of you have been told since childhood that guys don't cry. Have you been told so many times that? You are a guy, you're not supposed to cry at any cost. For some stupid reason that's been put in your head. It's like, yeah. No, back in the day, I understand slavery and all the stuff. Yeah, why did blacks not make white slaves? I don't know, for some reason. Yeah, and that girls love pink. Yeah, that's it put in your heads, okay? It's just that these are stereotypical, typical things. These are imaginary at the end of the day. And boys love red. When did that happen? Same for gender roles. Yeah. Not on gay couples and stuff like that. Yeah. Yeah. There's not one gay couple. I don't know. That's the thing. Yeah. Also, one more thing I just tried to add. I think I told you about this. Neanderthals were the only ones who were erased from the planet because they could not imagine something that was imaginary. Okay. These were the people who could not imagine imaginary stuff. That made the difference. Okay. Now, Neanderthals actually were great. They were stronger than us, more muscular, more powerful. Okay. And it's just that, what do you say? They were much stronger than us. Okay. They were entire species, guys, entire species walking amid us. Okay. But we killed them. We literally erased them from the planet. We don't have a pic. This is a wax museum, this thing, sculpture of a Neanderthal in a museum. Their lifespan was short. I don't know that, but the point is, we killed them. We literally erased them. We ate their food. It's like, imagine all the cats killed, all the tigers killed all the cats. Okay, they look like us. Okay, but these are little ones. We need to kill them. Don't want from the planet. Okay, it's like, imagine that. So the one thing they say, what killed Neanderthals is that they didn't. How many of you have read this book, Sapiens? I think I recommended it, right? Sapiens. Sapiens. That is a book you need to read. Please, I recommend it a lot. Okay, it's some of you might get interested in social science for the first time and anthropology. Yeah, it's an amazing book. Okay, that book actually mentions about why Neanderthals got erased, because these people had a tough time believing in nations. They could not believe in concept of nations. They could not believe in a religion. They did not have a religion. They could not believe in ideas such as something superior out there. Okay, and that is problematic, because if you don't believe in fiction, you can't form large groups. Okay, so many Christians, there are about so many Christians around the world. They are loyal to one guy who's in Rome. Okay, even though people are separated, it's called the Pope. Yeah, but the idea is, it's in their heads, right? People's head. But you can form a community that spans roughly about 1 billion around the world just because of some idea in the head. You can form a group which can fight against others, call it a nation, and draw a border and group a bunch of people to fight with another group, which Neanderthals could not do. They could not form a population larger group larger than 200. They could not go greater than that, no matter how hard they tried. Okay, and that's why they failed. So this very idea that we have religion and all this stuff is probably what saved us, kind of. Okay, these fictional ideas. We can believe in stories. I don't think you can tell a cat a story and listen to you. It'll just wag its tail and just run away. Yeah, I know. Tribes also have religion. So my point is, yes, imaginary concepts, they exist. Just an introduction to imaginary parts. Were actually having Indo, and somebody was like Indian Christians were actually having Indo ancestry. Yeah, it's a blend. Oh, by the way, fun fact, did you know most of the Brahmins in Mangalore are actually from Europe? Fun fact, if you didn't know that. Yeah, whoever particularly has not brown eyes, special different kind of eyes, particularly the Brahmins, they are not from this thing. Okay, something you need to know. Yeah, but you were actually, I think one of the kings here, I think there's a story, I don't know the exact story. What happened was one ship came and landed in the beaches of Malpe for somewhere, I don't know. And the local king was like, we need to capture these people. And I think they took women as wives. And I think most of the Brahmins, they made them Brahmins for some reason, I don't know why. Yeah. Yeah, Brahmin, they say the brown eyes are the Pakka local. My professor told me, I don't know this exactly where the source of information comes from, but the ones with the brown eyes specifically are the Pakka local Brahmins, and then, yeah, something like that. Anyways, with that being said, just need to tell you about some properties, but I don't think you need this. I don't want it. You don't need this. Okay. This is something like what I would do in PUC, so I'll just skip this. Now, what matters is the next part. Murali is munching itself. Is it bothering you guys? Nah. Okay. Okay. Now, representation. So this is slightly tricky to explain. I'll go really quick with this. It's a little tricky. I need a bakra. I need someone who's going to regret this a lot. Again, I'm telling you. Remember the time you guys decided to be part of an example and you regretted? Yeah, this is going to be one of those moments. Okay, who's ready to go now? You just mention your name and we'll go with it. Okay, Pratisha. We'll go with Pratisha. So Pratisha said she wants to go with this. Okay, now let's go with Pratisha. Pratisha, listen up. Let's say I want to know something. Okay. By the way, you're going to be a huge bakra here. Okay, get ready for this. So let's just say I want to know some information. I'm interested in the following information. I want you to tell me the location of your crush from your house. How far or whatever. If you want to tell me, how would you tell me? What would be the information that you would give me? You could use vectors maybe, but what else? How would you specify it to me? I bet this example stays in your head for a very long time. How would you specify it? Tell me the location. Pratisha is like, why? Why me? Okay, right now. Okay, you tell the place name maybe, but from your house if you want to pinpoint the location. From your house, if you want to pinpoint. Yeah, you asked for it, I know. How do you specify? Not Malpe Beach, dude. Look, would you use something like 4 kilometers east and 3 kilometers north? That would work. That's logical. That can work. Agree with that? That would work. I'm poor at directions, it seems. Okay, fine. Okay, if you're poor, can anybody help me with it? Can we put a location? Can we, I don't know, pick somebody there? Yeah. Can you tell me the location roughly? How would you specify? Can you specify it like this, like 3 kilometers and then 4 kilometers like this? This would work. Yeah. Why me? You chose. Okay. Yeah. I think I asked the same question while teaching vectors. Yeah. Basically, you could specify locate it that way. Okay. You could locate it that way. I don't know why 4 and 3 are like this, but 4 kilometers. But then there is one more way of locating someone. Okay. And this is interesting. I have a question. Yeah, one question. Listen to this. Have you ever experienced this when somebody, I think I've discussed this, I don't know. You come to, I don't know, you meet your friend in a room, like you just go up to your friend, and then suddenly your friend says 12 o'clock or 3 o'clock. Has this happened to you? Your friend saying that 12 o'clock or 3 o'clock. This is common in a conversation. Some of you might have experienced, some of you may not. Saying they say 12 o'clock or 3 o'clock. Yeah. Why do they use it? Military uses it, I know. Why do they say it in movies also? Watch your 12 o'clock. Okay. Yeah, I'm going this, Shashank. One second. Yeah. So do you see, you can also specify. So for example, if somebody annoying enters the room, let's say your annoying relative enters the room, and you don't want to take that person's name. You'll be like, dude, Calvin, look, Calvin, 12 o'clock. Okay, 12 o'clock. It's immediately tells him which way to look. Look, ahead of him it's 12 o'clock, 3 o'clock is this way, 4 o'clock is that way, and stuff like that. So that's usually tells you which direction to pinpoint. Okay, it's a common thing used. My point here is very simple. You can specify the location of someone without using always a Cartesian system, using 4 and 3. You can use an arrow indicating a direction, which direction to go, and you can indicate how far the person is. Is that fine? Okay. Like for example, I can locate something. Let's say there is, I don't know, the Pratisha's crush maybe, and I can say the person is 5 kilometers at an angle of exactly 36 degrees this way. That also works, right? Yeah, we can pinpoint the location, not a problem. Okay, yeah. I need not have to use, somebody saying use Google Maps. Okay, fine. I need not have to exactly use, let's say, 4,3 or something like that. Yeah. So you can use it. You can, because I'm crazy. I can use that. Okay. Why are you guys assuming it's a he? Okay, this person can be a she, guy. Be open-minded. Come on. Okay. Anyways, with that being said, why stereotype? Okay, Pratisha regrets this a lot right now. Okay. Anyways, with that being said, yeah, it may not be Virat Kohli. It could be, I don't know, Deepika Padukone too. Okay. Anyways, with that being said, so this is the location of the crush. So I can locate it using 5 kilometers at some angle. Okay, that'll go. Okay. Yeah. Anyways, with that being said, so this new system of information is called the polar coordinate system. How many of you heard of the polar coordinate system? It's a most commonly used system in, I don't know, physics. It's a favorite. People love this. By the way, physicists don't like this. Fun fact. This is for kids. We keep using this a lot, but this is used in radar and many things. Okay, I'll tell you why this is so useful. I'll give an example. I know particularly a set of physics problems. There is a particular famous physics problem called hydrogen atom. Okay, solving the hydrogen atom. You know those orbitals, those weird shaped orbitals and stuff like that. I'm terrible at drawing orbitals. Looks like a ring, a rose, or whatever the ring is. But you get the idea, right? This solution is actually 10 pages long, guys. Dumbbell shaped, whatever. It is 10 pages. Okay, roughly, if you scribble it on a sheet of paper. It can take about 10 pages of scribbling, and you ultimately will be getting, I know, I'm terrible at drawing, I know that. Okay, yeah, better? Nah, still no. Okay, it doesn't get better. So the idea is, it requires 10 pages to solve, but then if you use Cartesian system, but here's the amazing part. If you accidentally, even if you do a transformation in the beginning to Cartesian system, to polar system, this problem can be solved in less than 2 pages. The difference is that much. Okay, you will die if you solve this problem in the Cartesian system because it's lengthy, complicated integrals and whatnot. Okay, 2 pages is long, I understand, but then think of the difference, 10 pages to 2 pages, just because you were smart enough to realize this coordinate system is better for that problem. Okay, so always remember this. From now on, physics is going to become more like you figuring out which coordinate system works better. Okay, you'll know why better. For example, if you're dealing with the planets going around in motions, would you use Cartesian? Tell me. Is it common sense for tracking planets going around the sun? They go in circular orbits, and this makes more sense. Its radius hardly changes, very less, probably, but only the angle keeps changing, if you think about it. Yeah, submarines also use it. I know it's ellipses, but even ellipses have simpler equations in this case. Yeah, this is called polar coordinate system. It's called polar. Okay, this is called Cartesian under Descartes. So there are many systems out there. Okay, now I'll just go quickly over this. If you think about it, I can write 4,3 as 5,36 point this thing. Do you agree with that? Instead of specifying these two numbers to specify the location of someone, I can always specify 5,36.86. Agree with this? To tell somebody's location. Okay, so my point is, there's a way to transform. Instead of saying these two numbers, I can always say these two numbers in 2-dimensional plane. If it was 3 dimensions, it could have been 3 numbers. But in 2 dimensions, it's going to be 2 numbers. I just require 2 numbers and I can specify the location of someone. Is this fine? Fine, Pratisha? Okay. Anyways, don't be shy. Okay. Wait a second. Using you wait, I'll come to that. I know. Pratisha, Shashank, I'm coming to that. Yeah. Now, so in this case, if you think about it, this is 0, 3. Okay, this point can be located using 3, 90 degrees. Agree with that? Agree with that? 3, 90 degrees, 0, 3 can be represented this way. So my point is, this is transformation. Now, what's the advantage of a transformation like this? Okay, for complex numbers, this doesn't make sense. This one makes the least sense. For example, x, y makes the least sense. The Cartesian, the system where you write 2 plus 3i, it is not so useful. Okay, why polar coordinates? I know. I'll come to that. Why polar coordinates make sense? When you think about it, by the way, you know the transformation equations, right? Between them. If you have 4, how did I get this 4, 3? 5 times cos theta and 5 times sin theta. Agree with that? Is it too tricky? Can I get a yes on that? Look, if I want to know, if you give me the angle 36 and this thing, I can find out what is x and y. Yeah, just by plugging in. So you get using these equations. You can use these equations and get it. Okay. So the general transformation equation between then x and y is r cos theta and r sin theta. Is this fine? I know this will get a little bit boring, but listen to this. Fine. Yeah. So if you want, if I give you, I'll give an example. What if I give you 1 and 45 degrees? Tell me, what is it? 1 and 45 degrees. Sorry, root 2 and 45 degrees. What is it then in terms of x and y? This is in polar. What is it in Cartesian? Come on, tell me. You guys figure it out. Yeah, some of you are right. No. Just go with the 1, 1. Agree with that? It's 1, 1. Not 1 plus I, 1, 1. Is it fine? 1, 1. Okay. Now, but this is 1, 1. You guys are right. So this is root 2 and 45. If I give you, it's 1, 1. Similarly, backward transformations exist. That is, r is equal to x square plus y square, and theta is equal to tan inverse of y by x, something like this. No, just plug in the values for here. Root 2 times cos 45. That gives you 1. Okay, root 2 times sine 45 gives you 1 also. Okay, you just have to plug in values there. It's the same thing. So for example, cos 45 is 1 by root 2. Is it fine? Does this make sense now? Y 1, 1. X and y are 1 and 1. Whoever asked me to repeat. Okay, clear? Okay, but why do we separate with a comma? That's because comma, this thing, right? What do you say, x, y. But then if you're dealing with complex numbers, then it's tricky. It's x plus iy. Is it fine? If you're dealing with complex numbers, then it's x plus iy. So I can do a transformation. So for example, from now on, whenever I see an x plus iy, I can write it as r cos theta plus I r sin theta. I'll come to polar coordinates make more sense. That's why. Oh, by the way, I forgot to root this. Sorry. Yeah. Fine with this? Can I get a yes on this? Just plugging in. Instead of writing x plus iy, I can write r cos theta plus r sin theta from now on. I can write a complex number as root 2 times cos 45 in terms of cos 45 and the same plus I times root 2 times sin 45. Notice I'm just using 45 and root 2 everywhere. Okay, I'm using root 2 and 45 everywhere. Instead of using 1, 1 plus I can write it this way. Now this looks ugly, guys. Do you agree with that? Is this more, which one is more beautiful? Come on, tell me. From your personal experience, which one? The left hand side or the right hand side? Honestly. 1 plus I looks beautiful, right? This is damn ugly. Yeah, I agree with that. Root 2 plus cos 45. This is too much. Okay, this doesn't make sense. Now, the left hand side looks beautiful. I understand. Now, here comes the awesome part. Can I take r common out? I can take r common out. Looks a little bit more beautiful. So root 2 times cos 45 plus I sin 45. Ugly still? Yeah, this, I know, this look makes things, yeah, now, okay, now listen to this. Now comes the good part. Now, instead of writing this, I can write this. Good so far. Now, somebody came up with a strategy. Now, this person's name you guys know very well. He came up with an amazing strategy. And he was like, what if, instead of writing it this way, we write it in a better way? Euler. I was like, how can I simplify this crazy, stupid looking thing? Okay, this looks really, really stupid. I need to simplify this crappy thing that's out there. Okay, and he came up with a formula. And this is genius, the way what he came up with. It's called Euler's formula. Okay, there's something, this is said to be the E equals mc square of mathematics. I'll come to why this is so, okay, in some time. This, if you want to understand how the transformation and derivation comes, you can watch this on your own. Okay, there's a video by Mathlogger, E power I pi for dummies. You can check. It's the most beautiful equation, I know that. The derivation is there. I'm not doing this. This I would do it in PUC, but not here. Check it. Yes, this is what was discovered. It was discovered that cos x plus I sin x can be written as e power ix. Okay, so I'll just give you an example. Cos 45 degrees plus I sin 45 degrees can be written as e power I 45 degrees. E is a number called 2.718 something. I don't know. Some of you might know. Yeah. Yeah, Euler skipped complex numbers. He avoided imaginary numbers. Just avoided. But it was unavoidable. Yeah, by the way, we use radians here as much as possible. We use pi by 4 instead of 45. Okay, this is 45. It's pi by 4. Fine with that. You just have to take my word for it that this can be done so. Okay, there's a lengthy derivation for it, but cos x can be written as e power I pi ix. Now I know like this looks strange. I have taken e square, I've done 2 square, but what is this 2 power I something? This is strange. Yeah, but you can do it. Okay. Now, why is this useful? Once you understand this, that this can be written in simple form, you get a Chota package. This little thing that you had earlier now becomes so small, cute, isn't it? Very, very small. R is as it is, but this is e power I theta. Don't you love it? I love it. Cute, right? For example, I'll give an example. Earlier you had 1 plus I. Now this becomes root 2 times e power I pi by 4, 45 degrees. Yeah. 1 second. What is e power? Yeah, that's what I'm saying to say. E power I times x, root of -1 that comes there. Yeah, I know. My idea of lovable stuff sucks. Yeah, but no, my point is just saying that this is beautiful. Okay, I'm crying out of this thing. Yeah, this is simpler, and I'll tell you why this is awesome. Okay, finally, this starts making sense. Why? Okay, why earlier? Do you remember arguments got added up? Ever remember arguments got added up? Why arguments got added up? Now it makes sense. When you multiply two complex numbers, e power IA into e power IB, what is that? E power I, A plus B, right? Seeing the logic? Now why the arguments are getting added? Pratisha, it was, I think, Samant. Okay. E is a number, 2.71 something. It's a number. Is your crush this formula by any chance? No, it's definitely not. Okay. Is this fine? So now you're understanding why theta gets added up, why the arguments get added up. Now it should make sense. Okay. Where did exponents pop up? I'm just saying if you have a complex number in this form, okay, like root 2 times. Okay, tell me. A simple question, guys. What is 1 plus I the whole square? Tell me quickly. Quickly tell me what is 1 plus I the whole square. Come on, guys, quickly. 1 plus I the whole square. I'm going to do it in my way, okay? Root 2 times e power I pi by 4, the whole square is equal to, root 2 square is 2 into e power I pi by 2. Yeah. This is nothing but done. Okay, most of you told me it's 2i, right? Agree with that? Okay, convert for me what is 1 plus I into polar form. Do you agree it's root 2 into e power I pi by 4? Agree with this? 45 degrees and root 2. Can I get a yes or no on that? Is that part clear? 1 plus I is root 2 into e power I pi by 4. Okay, this is the polar form. Okay, this is a polar form of it because this is r, the distance from the origin, and e power I pi by 4 is the angle that it makes, 45 degrees with this thing. Is this fine? Okay. Where do you get root 2? Root 2 is 1 plus 1 square plus 1 square, the distance. Root 2. 1 square plus 1 square. 1 plus 1 9. Okay. Hope you guys got that bit. Now tell me what is 1 plus I. Tell me what is I, 0 plus I. In polar form, what is it? What is the modulus of I? What's the magnitude of I? 1, right? Yeah. But what about the angle E makes? What's the argument of I? 90 degrees. That'll be e power I pi by 2. 1 because the length is 1. I don't know, magnitude is 1 simply. Square root of 0 square plus 1 square is 1. Okay. How 90, I don't know, imagination guys. You can do it, tan inverse of this thing, but I is here and this angle is 90 degrees. Is this fine? Okay, this might be confusing for some of you. We need to do a recap of what is, quickly. Guys, complex plane, tilted axis, and the imaginary part, real part. This is I, this is 1, this is 2, this is minus 1. Tell me what is the argument of I? What is the angle of I? What is the argument of I? Quickly. What angle does I do with the positive real axis? 90 degrees. So the argument is 90 degrees. Yeah, 90 degrees argument. Okay, what's the argument of 1? 1. Argument of 1. 0 degrees. Is this fine, everybody? It makes an angle of 0 degrees. Okay, what is the argument of minus 1? What's the argument of minus 1? 180 degrees. Okay, or pi in other words. Okay, this is pi by 2 and this is pi. Okay. Okay, 1 second. Yeah, if that is fine, if that is understood, now listen to this bit. Can it be minus 180? It can be minus 180 also. Minus 180 works. Yeah, it can be 0 or 360 degree. Even 360 degree will work for this. Okay, if that part is clear, what about the modulus of I? What is 1 plus I? What's the modulus of 1 plus I? Quickly tell me. Root 2, right? That is 1 square plus 1 square. What is the modulus of I? Just I. It's 1. Okay. What about the modulus of 1? 1, right? Logical. Now, the idea is, this is the distance, this is a modulus. And a complex number I told you, x plus iy, can be written in terms of r into e power I theta, which means instead of writing 1 plus I can write r, that is its distance from the origin, root 2, e power I pi by 4, its angle, 45 degree argument. How is mod of 1 plus I root 2? That is square root of 1 square plus 1 square, a plus ib. Modulus of a plus ib is root of a square plus b square, Pythagoras theorem, the distance from the origin that it makes with the complex number. Is this fine? But I square is, no, modulus. Oh, you're not taking I, you're just taking the part of it, 1, you're just taking 1. You're taking the imaginary part, not I. If it's 4 plus 3i, you're taking the modulus, you won't take 3i. You will take only 4 square plus 3 square. Is this fine? Yeah, there'll be a quiz today. Yeah, after this at 7 o'clock. Diagonal of a unit square. Yes, root 2. Yeah. By the way, there's a quiz now at around 6:45. No, not 6:45. We'll keep it at 6:40. Okay, is it fine? Till then, I'll take questions if there are any questions. I think it's a break right now for you guys. You guys can make a move. if you guys are done. Yeah, I just need to summarize, okay, for some of you. Okay, so the idea is in complex numbers, there are two concepts. One is called angle that it makes, that is the argument. Quiz is at 6:40. Okay. Listen to this. This is the argument. This is the angle that it makes with the real axis. And then there is something called distance, r, how far it is. Now, how far a complex number is from the origin, that can be, if it's x plus iy, then you can give a square root of x square plus y square. Pythagoras theorem. That is r, or the modulus. And if you want the angle will be something that you can observe or you can calculate as tan inverse of y by x. For example, if it is, let's say, 1 plus I, then its modulus is square root of 1 square. 1 plus I can be written as 1 plus 1I, right? So it is 1 square plus 1 square. That gives you root 2. So this is root 2. If this is 1 plus I, this is root 2. The angle it makes is about 45 degrees because it's tan inverse of 1 by 1. 1 by 1. So the point is, you can represent a complex number 1 plus I as root 2 and 45 degrees. Yeah. Okay, so that's the brief idea about it. Okay, that's a brief idea about Furlar transformation. You can transform, you can write x plus I by like 1 plus I is equal to root 2 times e power I 45 degrees or pi by 4 in radians. Okay. I think the scores are not updated or updated, I don't know, but I think I released your scores for the previous exam. Okay, any other questions? What is the value of I? Root of minus 1. I is root of minus 1 still. I just remember reading something about use of complex and coordinate geometry and bit of how is it used. Yeah, they make problem solving easier. I know. Complex numbers make things easier. I know, but I don't think I have the time to go through it. 1 second. I found an answer for Mary's thought experiment that could be. I didn't still watch the Mary's thought experiment, so I won't think I'll be able to answer. For breakthrough, how much should I simplify the stuff I'm explaining? Okay. Okay. So the idea is you need to try something like Vsauce. You need to explain something that's in simple words, but okay, something that a 10th standard student would understand or an 8th standard student would understand, but yet that can be slightly complicated and still amazes the judges. Somebody, even eye watching, should be something like amazed. Okay, I never thought about it that way. That's what people look for. So when you're explaining, you got to make sure you have the city, but do something very interesting. For example, in the 2017 winners video, what she did is that there was this Doppler effect. She did Doppler effect. So there was a car going and there were waves produced. You know that the waves get compressed when a car goes closer, right? You guys know that? That waves get more and more compressed and waves get more and more spread out if something honks and goes away. Yeah, but she was like, what if, this blew my mind in that video. I never thought about it that way. So like, if you stand here, if I stand here, I'll observe the pitch to be 430 hertz or something, 35 hertz. Okay, but if somebody stands somewhere a little bit far, they might see 460 hertz or something hertz. But the idea she was trying to propagate was, if you stand everywhere in space, if there was multiple me's out there, many people like me, they would hear different frequencies at different points, which I'd never thought of. I mean, Doppler effect actually compresses along one line and shrinks along. But since Doppler effect is actually two-dimensional, which I'd never thought about in my head, I realized immediately that people experience all the frequencies that there are because it's two-dimensional. So, and a ball which is moving through space at some speed of light, very high speeds, we'll see it bluish in one direction, we'll see it reddish in the other direction. But I just realized at that instant, I'll see it in all the other colors as it moves through space, which I had never known about. But it was a simple concept which I'd seen already, but never thought about it that way. So that element matters, is my point. That element matters a lot, and it's a winning element. You do not have a lot of winning elements now because I know it's too late. In the short duration, it's hard to make a video which can achieve that. But I think you still have 1 year for the next one. So that's when you can plan it really well. In case. Quiz is in Google Classroom. Yes, it'll be in Google Classroom. Yeah. It'll be in Google Classroom. I've released your marks, Kalpana Chawla, specifically. Yes, I have. Oh, yeah, you guys can leave, Shashank. Yeah. Can I? Yeah, Shashank. Yeah. I may not be right, but the formula for Doppler shift is independent in speed of the source and the detector, right? No, it depends both on speed of the source and the person who's detecting it. It's a relative motion. Depends on both. Every go to Google Classroom. Keaton, your situation is an annoying one. I'll figure it out. There's no greeting period. I got it. I'll speak with the office about that. Okay. Quiz on today's topic is complex numbers. Okay, you'll have to bear me for that. Test and DPP and test grades. Okay, 1 second. Lens law grading. Okay, lens law, I'm not sure yet. So test on Thursday. Yeah, there's a test on Thursday, I heard. Sir, everybody stationed, then the resource will be constant, right? And so the speed of the apparent frequency measured remains the same. Everybody stationary. Yeah, if things are moving, then both of them matter. The relative motion between the source and this thing matters. Yeah, Anika, that's true. Yeah, that's happening. Quiz is not posted yet, I know. I've upgraded Windows 10. Could you instruction for? Yeah, I'll do that during the sessions. Is it fine? The coding sessions instructions, because of the first class won't be exactly on that, but yeah, I'll try posting this thing. What is that? A set of instructions. I'll prepare one. I'll post it on Google Classroom because I've completely moved to Google Classroom than Schoology. How much time is left for this lesson? This lesson is done, guys. Complex numbers is almost done. I'm just doing the last bits of it. Some advanced bits, just to give an idea. The coding class could be next Sunday, probably. Okay, it could be next Sunday. 1 second, I'll assign you guys the quiz. Algebra comes under quizzes. Due date is 7/15. Yeah. Yeah, I think after you finish this, then what? Yeah, there's a lot of things. 1 second. I'll just post your quiz, then we can talk. Grade importing, done. Yes, assigning. Okay, so somebody asked, are you, then what? So what do you think? Is it possible for measuring if the detector is stationary, because mathematically then speed of the detector and speed of the source is constant because there's no apparent frequency still remains the same? Yeah, kind of. But the medium matters. See the speed of, look, you forgot one more thing. The medium matters. Okay, if the medium is moving with it, then that's a different story. So there's an ideal frame in which the medium is constant. What is something to the power I? I'll come to that next class. Okay, that's next class. You'll understand it once I did this polar form. All the questions will get answered finally. Okay, I think I've assigned the complex numbers quiz. Yeah. Is there a CFL textbook material of this? No, sadly it's not in. So, but I have a material on my website which you can check for. It's under complex numbers. I had done it long back, the topic. So it's there if you're interested. That can act like a notes. In fact, I think CFL will be taking that as a material. So if you're interested, go to teaching and courses, go to complex numbers. This is actually advanced and written for first PUC. But if you're interested, you can go to lecture notes. First one. Okay, in this you will be able to get the notes, whatever you require. Whatever I did in class, that's explained better there. If you want to really understand. What's the password? There's no password for this. For this lecture notes, there's no password. You can directly get it. Okay, it's on Firebase and you can download it. Lecture 1. There's no PPT for it. So this is 8 or 9, but every answer is correct. I don't think so. Some answer you got it wrong. I'm sorry. You've gotten something wrong. Okay. Induction PPT, yeah, I'll try uploading tomorrow, today. Air is moving, but air is moving for every observer, right? And has a different density, so it's observer, right? Look, I think it depends on the speed. See, it depends on two things: speed of the source and the speed of the observer, both of them. Because if I'm moving closer, faster towards the waves, I'm adding, the waves get more compressed for me. One has two right in the quiz. What, I didn't get that. Can you type that again? Is Z minus conjugate of Z? No. Conjugate is you replace everything by minus I. Wherever there's an I, you replace it with minus I. That's conjugate. Yeah. This is slightly advanced, guys. What I'm trying to do is a little bit advanced. Okay. Should we write integer part of the imaginary part or everything? I think you're asked only to write the integer part, right? Yeah, just the integer part. Imaginary part means two options. So you have to answer. If you have answered one, you won't get 1 mark. No. Both, if you have ticked two options and if two options are correct, both have to be ticked. Only then you get the marks. If the speed of the data and speed of the source is the same, yeah, but then the direction of the speed matters. If they're going in front or going at the back, coming towards you or coming away, minus 6 or plus x matter, both matter. Is it plus v or minus v? That also matters. Look at the formula for Doppler shift. You'll get an idea what I'm talking about. Yeah. Please take the quiz, guys. I think I'll see you guys later. Is there any questions regarding the quiz? Discuss tomorrow or the after tomorrow. This is a very advanced topic, complex numbers. It's not so simple. Most of you take a lot of time to get used to this. Okay, so if you've understood a little bit, that's good enough for now. It's complex conjugate and complex conjugate. What? I didn't get that. Okay, induction PPT, yeah, it'll be sent to you. Okay, induction will be sent to you. Yeah, okay, cool. So see you guys. I think there's nothing much. Yeah, cool. Pratisha will be sent to you. I'll send the PPTs soon. Okay, I think that's about it. See you guys.